Okay. We can start, Krishna.
Okay, sir. Good morning to everyone present here. On behalf of the Department of Biotechnology and Bioengineering, School of Biosciences and Technology, in collaboration with the Institution Innovation Council, IIC, Galgotias University, it gives me immense pleasure to welcome you all to today's expert talk titled AI and Innovation Sprints Rapid Prototyping for Digital Transformation AI in Healthcare and Biomedical Application. We are delighted to see the enthusiastic participation of faculty members, researchers, students, and innovators from diverse backgrounds. I extend a warm and respectful welcome to all the dignitaries, esteemed faculty members, invited speaker, and all participants who have joined us online today. Your presence truly adds value to this academic initiative. Now, to formally begin the program, it is my privilege to invite Dr. Gaurav Kumar, Head Department of Biotechnology and Bioengineering, School of Biosciences and Technology, and Head Institution Innovation Council, IIC Galgotias University, to deliver the opening address and share his insights on the importance of innovation driver interdisciplinary learning, and the relevance of AI in healthcare and biomedical sciences. Sir, we request you to kindly address the gathering.
Okay, thank you. Thank you, Krishna. Good morning, everyone. All respected teacher present here, invited speaker, and all the student participants. On behalf of Department of Biotechnology and Bioengineering, School of Biosciences and Technology, and the Institution Innovation Council, Galgotia University, I warmly welcome you all to participate in this expert session on AI and innovation sprint, rapid prototyping for digital transformation. This workshop has a certain theme like AI in healthcare and biomedical application. So in today rapid evolving world, innovation is no longer limited to a single discipline. Innovation can occur in each and every field in various disciplines. The most impactful solution in healthcare emerge when biotechnology, bioengineering, imaging, and artificial intelligence come together. So this interdisciplinary approach is essential for the addressing real-world challenge such as faster diagnosis, improved medical imaging, and a smarter healthcare delivery. So as part of this workshop, we aim to encourage you all to uh, make this event successful by asking several questions to our invited speaker during the question answer session. For your active participation, you can interact, make this session very interactive, and you can learn. I hope that you will learn innovation, rapid prototyping, and real world implementation of AI. So we are truly privileged to have Dr. Munendra Singh sir with us today. And sir, we sincerely thank you for accepting our invitation and for taking time to share your expertise and valuable insight with your participant. So I am confident this session will be highly informative and inspiring and interactive to all. So thank you once again. Thank you. Over to you, Chris.
Thank you
Yeah,
so much, sir, for your motivating words and for setting the context of today's program so effectively. Now, it is my honor to introduce today's distinguished resource person whose academic journey and research contribution truly exemplify excellence at the intersection of engineering, AI, and healthcare. Dr. Munendra Singh is currently serving as an assistant professor in the Department of Electronics and Communication Engineering at the National Institute of Technology, Jamshedpur. Prior to his current role, Dr. Singh completed his postdoctoral research training at the MR Research Division, Johns Hopkins University, USA, from June 2021 to October 2024, one of the world's leading centers for medical imaging research. Before this, he worked as an assistant professor at Manipal Institute of Technology, Manipal, where he was actively involved in teaching and research in deep learning and image processing for over 2.5 years. Dr. Singh's core research expertise lies in physics-informed deep learning-based solution for MRI data reconstruction and quantification. His work has made significant contribution towards quantifying multiple tissue parameters from a single MRI scan of the human brain and reducing overall MRI scan time, thereby improving clinical efficiency and patient comfort. He completed his PhD in 2019 from the Indian Institute of Technology, Banaras Hindu University, Varanasi, with a doctoral thesis focused on optimization technique based algorithm for denoising, enhancement, and segmentation of MRI data. Dr. Singh earned his master degree in instrumentation engineering from NIT Kurukshetra in 2012 and his bachelor degree in electronics and communication engineering from UIET CSGM University, Kanpur in 2010. Sir, we are truly privileged to have such an accomplished academician and researcher with us today. With a great respect and enthusiasm, I now invite Dr. Munendra Singh to deliver his expert lecture on AI and innovation sprints, rapid prototyping for digital transformation, AI in healthcare and biomedical application. Sir, the virtual platform is yours. I request sir to share his screen and begin the session.
Okay, am I audible, Krishna?
Yes, sir, you are totally audible.
Okay, thank you, Krishna, for such a nice introduction, and thank you, Dr. Gaurav, for giving me this opportunity to present here. Okay, so I think now we can start. Let me share my screen. So I can share my entire screen. Share. Okay. So today's talk is on artificial intelligence and machine learning in general healthcare. But since my focus area is medical imaging, so I thought of I will discuss. I will take you towards the medical imaging side. Okay. So in this talk, very first, I will discuss brief about in general AI because nowadays. Students and so many people know about the AI, but they don't know how it started, what are its components. Then I will take you towards the medical imaging, right? So let's start. So very first, I got this quote from somewhere that it happened gradually and then suddenly. AI is not a very new thing. Means since long time people were trying to means develop AI frameworks, and then in few years back, AI has become a buzzword, and everywhere you are hearing about AI. In fact, 2 days back in the budget session, so many times AI came, right? So now it's very sudden. So how it started, we will discuss. So I believe that this is the one image you would have seen previously, but still I kept it here. And this is a word of artificial intelligence. As so, let me take some screen pointer. Okay, so I kept this image here because nowadays you are hearing so many words like artificial intelligence, machine learning, neural networks, deep learning, what they are, and means and what is their relation between them. So here you see this is a very broad area, that is a AI, artificial intelligence. Here we have NLP, that is natural language processing, expert system, fuzzy system also comes in this area, optimization methods, evolutionary computation, all comes in this area, artificial intelligence. This is a very big domain. And inside this domain, we have a machine learning. So as you know that machine learning, as name suggests, you require some learning, but in artificial intelligence in general you don't require learning always. Sometimes you have certain methods based, those are depends upon mathematical model, so they have limited intelligence. But this comes in the artificial intelligence, but machine learning essentially required the data to learn. After that, neural networks. So here we have neural networks to use to learn the data, to learn the data. So this is a specific method. So with that we can learn the data. Okay, here we have recurrent neural network, LSTM, BiLSTM, MLP. So many methods are here. And nowadays, the whole focus concepted towards the deep learning. So deep learning is a specific type of neural networks that have a multiple layers in between, and it learns data. Even very complex data, it can learn very complex relation between the input output. It can learn very easily. So if you would have heard about the GAN networks, CNN, all these networks are the deep learning. Just in case you have any question, please feel free to ask anytime during the presentation itself. So now the question is why AI is important. So we have seen that AI can solve so many problems, and it is a one example where we can see that AI is playing the chess game. So this is a one area people are working in AI, and because here you can see that AI can think, AI can take a decisions. This is another application of AI, automated speech recognition, and then you can convert text to speech, or sometimes speech to text you can convert. Okay, so now actually I don't need to show you all these images because you already know where people are using AI. But still, for just to begin start with, I thought of keeping this as well in the slides. And nowadays people are developing AI methods for chip design as well, like neuromorphic computing. You would have heard about that. Okay, and neuroprocessors are already in the market now. This is the speech this is a text to image. So few years back, around 2 3 years back, I have gone through one research paper. From that, for an image, the AI model was generating the caption. But nowadays, you see that this kind of softwares are already in market, and but to limited, but they are there. Okay, on your text, on your speech or text, they can generate images for you, but they're not that as much as good, but they are here. AI in defense, specifically in drone technology, in data link. So because in defense we have so many data, some data from we have drones, some data from satellites, some data we have from fighter jets, and how to link that data and take a decision is very important in defense nowadays. So AI is already there in defense, but it is very limited in India. But yeah, the other countries are already using AI in defense, like China and US. And this is the AI in protein folding pathway research. So I know that you already know that 2 years or 1 years back, three scientists from the Google DeepMind, they got the Nobel Prize. Uh, they got Nobel Prize for this research, where they really improved the accuracy of the alpha folding problem, and they able to predict the 3D structure of the protein from the given input, that was the amino acid. So AI had, we can see that in recently, in specifically after the COVID, AI gained so much attention in every field, everywhere people are using. That's why it's very important for us to understand start from AI from where it started and from where it is going, and what are the challenges in AI. Okay. So I would like to start the brief history of AI. So very first time, artificial intelligence as a term was used in the Dartmouth conference. So Dartmouth is actually an institute in US. So there, very first time, people thought about one field where a machine can think, and that time they give a term that is artificial intelligence, right? So this is the very first time. It was in 1956. So, but since then, a lot of research keep happened. People developed so many algorithms, so many mathematical models they developed, but AI was not popular. AI got popularity when in 1997 IBM developed a computer and that computer was named Deep Blue supercomputer, and that beat the chess grandmaster Gary Kasparov, right? Then people start talking about what is AI, how a computer can beat the chess grandmaster, right? And in 2018, since the generative model came, that time a very popular AI painting was sold. This is a painting generated by the AI. It was sold in around 0.5 million US dollar in New York. So now people start thinking, okay, AI can do anything. AI can do what will the role of the painters? What will the role of the bankers? What will the role of educators if AI is doing everything? Okay. And now recently we have seen that the program used to AI predict 3D structure of nearly every protein in the human body by the AlphaFold from the Google DeepMind that I discussed. They got the Nobel Prize for the same. Right, and this is the you can see there's another AI painting. It was thought of some painter has drawn this painting, but this is the AI generated painting. So this is this is the knowledge based system from where AI generally has started. People really start knowing about the AI, but that time AI was just a knowledge. Means if you have knowledge, you have power, like that. So AI started from the expert system. So if this happens, then this will happen, and based on that, they developed some algorithms, and based on algorithm, people start taking the decision, right? So the first application of AI have seen in the diagnosis of the blood infection, and based on that, they recommend the antibiotics. So for that, they developed the model name was the mycin. The expert system based AI techniques has been developed to infer the molecular structure from the mass spectroscopy, and the name was Dendral. Right. So this time, if and then condition knowledge based system, fuzzy system, helped to develop the AI model, and that was called the AI that time. So it has a lot of contribution in back then, because this was a really very first application where which has been used in industry. The very first AI application has been used in the industry, and it because of this kind of AI methods, there was the exponential growth in everywhere. People start saving the time, efficiency got improved. So many contributions it has that time. But always it's a problem that you cannot, it's very difficult to make deterministic rules, like if this happen, then this will happen, based on that this output. So it's very difficult, because you need a lot of knowledge to have a deterministic rules. And these are just deterministic rules. If this happen, this will happen, but somehow you have to model uncertainties in that. You have to learn from the data rather than on the written rules. So it's very difficult. So this made us a gap to evolve some new technology. So now again, I wanted to go back before I started talking about the artificial neural networks. I would like to tell you that means how artificial neural networks term came, from where it came. So it came in 1943. Even though when the AI, when the artificial intelligence term was given in 1956 in Dartmouth conference, before that, artificial neural network has been proposed. But that time the idea was not to learn something, not to take a decision on something, but the idea was just to tell how can you use these networks for a simple logic gates, right? So they are here. We can see this is a picture of McLeod and Bates. They both were the neuroscientists, and based on the neurons, how neuron behaves, they suggested some neuron circuit, based on how neuron works in our brain. So they had some flow circuits here. You can see that, and this was the base to develop artificial neural network in future. And this was the first paper. You can see that. And but again, this artificial neural network had demonstrated that how can you segregate how you can segregate, or how you can differentiate the two things, like in OR gate or maybe AND gate, NAND gate. So that means you can take a linear decision. But there was one paper that came in 1969, and this paper has demonstrated that the perceptron network based on the artificial neural network cannot differentiate or cannot solve the XOR problem. That means a nonlinear problem. It cannot solve a nonlinear problem. And because of this book, actually this book has suggested this thing. Because of this book, whole AI community got disappointed, and they thought, okay, now AI is now there is nothing in AI, because it cannot solve a nonlinear problem. It has a limited scope, and people were just distracted from that AI, and the amount of papers start coming that field were decreased. They got decreased over the time. But still, people were trying. There were certain people, though these people were trying that how to use AI, how to use really AI to solve nonlinear problems. For that, in 1986, they developed one method, that is a back propagation in multi-layer neural network. Because to solve the nonlinear problem, you require multiple layers. Because in perceptron learning, they were having only single layers. So they were having multiple layers in the model. And but how to differentiate, how to minimize the error with the help of back propagation, and that was the paper. You can see that. So and eventually this GE Hinton got the Nobel Prize for his contribution in the science, in the field of physics, right? Then people were, because of this paper, because of back propagation algorithm, people will start working in the AI. People were working in the AI, but it start getting the more popularity. And eventually in 1989, uh, Li Chun applied the convolutional neural networks to recognize the handwritten digit, on the chip code. Because that time we were writing the letters, and the chip code has been recognized by the AI algorithms, and for that he proposed a convolutional neural network. Right? You can see this example from that paper, and this is the original paper. Now, recently, I would say that recently, the convolutional neural network already proposed by the Li Chun, and then this network has been used to classify some data, just like dog and cat, tumor, non-tumor, so many things. So and that paper is the method they developed in that paper is called AlexNet. And that nowadays people are trying to people compare as a people compare their results with the AlexNet. So there are so many versions of AlexNet. People compare their paper with the AlexNet. So this paper has been developed in the 2012, and here you see GE Hinton. He got the Nobel Prize for developing for his contribution from back propagation to this AlexNet, and he's someone he's a student, and he's AlexNet at the center, right? So this from here, deep learning, basically people start using the deep learning. Before that, deep learning was not there, because people were using very few layers, and here AlexNet took the multiple layers to get some decision from the data and the model. So deep learning actually started evolving from here. And then from Google, there is one more kind of method I will discuss later on, that deep reinforcement learning. So this is a different kind of method where it can take a decision based on the learning till now. Means it keep learn always. So the deep reinforcement learning is a different kind of learning. Okay, so here you see that the decision is coming from the image to data, and here continuous learning is not required, but here continuous learning is required. And that the AlphaGo, that's a method developed by the DeepMind Google, and they defeated the world champion Lee Sedol in the AlphaGo game. Yeah, and here is the picture. You can see that, right? And but you are thinking, but since Gaurav sir also mentioned that this is a very interdisciplinary field, and AI is being applied nowadays in most of the fields nowadays. And the same way, I should say that previously the different fields contributed to develop the AI. For example, Bayes rule has been developed in 1763, and this rule came from the probability least square regression, developed for the astronomy, and we use least square regression as a linear regression nowadays, right? So these are we can say the first people believe that this is the first method for the machine learning. This is the most easiest, most simplest method, and we whenever we teach a student, we start from here. Maximum likelihood from statistics. So this method has been this kind of mathematics we use for logistic regressions, artificial neural networks, MacLeod pits. We have seen that they coined the term artificial neural networks based on the neural behavior in our brain. They were neuroscientists, and this whole concept came from neuroscience. And similarly, stochastic gradient descent for the optimization, how to find the weights and bias, it came from the optimization method. So different field together help AI to develop over the years. And now all the fields are enjoying what AI has been already developed, right? So now AI is being developed nowadays. So the research area, people are trying to do research in AI agents. That means that people are trying to improve the efficiency, accuracy of AI model, and they are trying to achieve human level intelligence. Right? They want best results, even they want to beat the human. Okay, and it's actually happening. But to get this kind of human level reasoning or human level intelligence is not possible yet, because whatever AI model we see, they are trained for a specific kind of task, right? Because but human knows so many things, but AI models has been developed for a specific task. They have very narrow task, and for that they learn from millions of examples. And then once they learn from millions of examples, then they try to predict. For example, they learn with the examples. Based on that, they can make some reasoning. Okay, this data can be used in the robotics, language, perception, knowledge, so many things. So this is one area people are using AI for different applications. They are trying to improve the accuracy. They are trying to improve the efficiency, right? So another area is people are thinking that how AI is going to impact our society. For example, what is the consequence of the AI on security, right? What is the consequence of AI on biases? Because AI is biased. A lot of people are keep talking about that. Who is developing AI? He thinks that's the correct way, and AI also learning that way. For example, here you can see whenever I tried to type nurse on the Google, and then try to find out the images. I found these images, right? Although here male or female, all are there as a nurse, right? So it's not biased to gender, because they already corrected this biasness. But it is very biased to few kind of people. You can see that here you see most of the people are white or black. The Asian, specifically South Asian, just like Indian population, is missing in these results. So because these algorithms is already trained, developed by the white or black people, and that's why AI is also biased to show some results based on that, and this AI model is accessing that data set, right? So main results are coming from this group. So this is one example how AI is biased, right? And other thing is security bias, because we are having in so many healthcare data, right? And this data is very personal data. For example, gene data means, and what disease particular patient have. This is very personal data, and the security is really very worrying with who is accessing data, if this data is safe or not, right? And this data can be manipulated to have wrong results. That is also an issue in that. For example, you see here, this is the people are fooling AI by having different classes, and AI start predicting some different results. This is how you can fool the AI as well. That's another question. So people are also thinking about the consequence of AI in society in general. So now, how to solve the AI? So here you see that this is a model before AI. So here we have a real problem, and means I wanted to go from this place to another place. So for that, we were having already a model. Our model means on based on our experience, based on experts, we know that what is the cost to reach from one place to another place. And let's say I wanted to go from this place to this place, and based on this fixed values that came from the expert system data, that is based on experience. So AI model told, okay, this is how I have to go here. Okay, but these things keep changes, because sometimes you have traffic, sometimes traffic is not there, sometimes you have a bad condition of road, sometimes you have good condition of roads. So environments always keep changing, so that this model are not effective. That's why we should have some model without the parameters, and then we have some data, historical data, weather data, or so many data we have, told data, and then based on that data, our model has to always learn the link or the strength between the two nodes here. So then it will tell how to then really we have data to learn this strength, rather than depending upon the experience, and then we can do some predictions once we have all learned parameters. Okay, to reach from here to here, and this could be dynamic. It could, for different weather, different weather, it can be different, or different time it can be different. Okay, it's under data. This is how we solve the problem. First we model the problem, then we collect the data, we train a network, we do the inference, right? So these are the steps. Now here, type of AI. So as in the very first slide, I have already shown you the very broad area AI. In the AI, we were having the machine learning, neural networks, and then deep learning. And then, if, in fact, this is a type of AI based on capability. So the machine learning or deep learning, then artificial narrow intelligence means, but in that case, we have AI model that has been trained on the very specific problem, right? Most of the models are like that. We train a model on a very specific problem. If you train, for example, if you're training model to just predict the tumor in the brain images, it cannot predict the tumor in the abdomen, in the liver. It cannot predict, because you trained model on that particular set of data, and that having very narrow intelligence. Similarly, there is another kind of AI based on capability, that artificial general intelligence. So it knows about several other things. If you, for example, if you're training, but you have to train in a different way. You're training something on a general signal, in general AI signal, in general MRI signals, and whether you are predicting the tumor in the brain, or whether you're predicting a tumor in the abdomen, anywhere like liver or somewhere, then still it should able to answer the question. So it's a in general intelligence. So this kind of approach we are trying to develop nowadays, and then ultimate goal is to artificial super intelligence, like it can take a decision by itself. AI model should have logic. AI model can see something. AI model can do the multiple tasks like a robot, AI based robot. Okay, so we have a AI based robot, but they are very limited and they can do a limited task. But this is, we cannot achieve the human level intelligence, so we call the artificial super intelligence. This is a hypothetical condition, yet that is yet to achieve. So this is another based on functionality. We have AI system, that's expert system based on the if then rules. Predictive AI we have nowadays, we call this predictive AI. Predictive AI means we can predict something based on the learning. So and that means we cannot have something new in that, but we have a generative AI. Generative AI, you already aware of generative AI nowadays, that it can generate new output for you that is unseen to the world. Like some images is generated, some text is generated that has never been seen based on your inputs. So that is called the generative AI. Now this is an example of AI expert system. So it is very fundamental, very basic, where this kind of methods people were using in the 80s, where there were several experts were there, and then these based on these experts, the knowledge dictionary has been made, knowledge has been developed, and that knowledge has been coded into the engine. Here I have mentioned the engine, but has been coded into the into the processor, and then user interface can ask a query, and it can give the advice based on that, in terms of text, in terms of voice, or anything, images. So now we can try to see the AI methods in terms of complexity, right? So so AI method can be classified in three classes. One is the reflex. Reflex have a very low level of intelligence, and another one is the logic, which is a very high level of intelligence, just for robots, right? That robot can do anything just like a human. There's a very high level of intelligence. Search problem, adversarial game states is a somewhere medium level of intelligence or complexity. So, for example, if I ask you to identify that animal, you already identify within a fraction of seconds, right? What was that animal? It was dinosaur. Everyone knows that. Similarly, AI, it was a dinosaur, right? So everyone knows that. And our mind, our brain took a very fraction of second to identify that animal. So this kind of methods we call the reflex-based method, and people are developing so many reflex-based methods nowadays. And these example of those methods are linear classifier, deep neural networks, or based on the reflex-based methods. And these are most commonly used models in the machine learning, and people think that is a machine learning actually. It's a synonyms of machine learning nowadays. People think that, not nowadays. So, but in that method, we don't require the tracking. But we don't need to check again, right? If it is means during the training, we don't need to check. We need to only forward direction. So, for example, this is one image, and from that image, the breast cancer has to identify whether it is a cancer or it's a normal, right? So this is a reflex based system people are developing. This requires, this is a very simple kind of model we have, right? So this is another kind of AI methods, state based models. So if I ask you to tell what is the next white move, which for white, which should be the next move, but it's very you will take a time to understand, and some people can say, okay, I don't know that. So so it is state based models. It requires it is a medium level of intelligence is required. So more methods are some intermediate level of complexity have. Okay, so so these kind of methods are state-based methods, and application of these methods are in games like chess, Go, etc. Robotics, in robotics, surgical robots, motion planning, how to move, what to pick, what to leave. All these requires the forward direction as well as the backward direction. Both logic works simultaneously. Okay. Natural language generation, text to text, text to image, image to text. So this is comes in the state-based models. Okay. Now we can move on the AI in medical imaging. Okay, so why AI matters in healthcare? Because of so much pressure is growing. We have shortage of healthcare experts, so AI is very much required. Right, the documentation burden is too much nowadays. So clinician job has to do. Clinician job should be to spend maximum time with the patient, but nowadays so much administrative work is there, right? So to documentation burden, we can reduce with the help of AI, and and the operational efficiency through AI we can improve, like administrative duties, significant boosting clinical productivity. We can use AI here in this domain, and the predictive and personalized care. So for accurate prediction of the patient, monitoring can be achieved with the help of AI. For each patient, therapies for particular patient, therapy is required or not required, when it is required, right? Which kind of therapy is required. So this is the personalized care is possible with the AI, and that is very difficult for clinician to do this job, right? Because they have so much burden of so many patients. So and clinician can also take a help from AI rather than completely depend upon them, and together they can work well. Now the question is, if you're wondering that how the image is, how machine understand the images, right? So machines means computer, right? So computer store, we have image, so computer store this image. So this image has so many pixels, so many pixels. For example, I don't know how many pixels it, in this image has, but let's assume 256 cross 256 image, the size of this image, then those many number of pixels it have, right? So these machines understand only the pixel values, and these values be for different images. For in general images, we get the unsigned integer 8 data, where we can have value 0 to 255, but in medical images typically we stored 12 to 16 with integers in TICOM format. It requires it provide us a more precision in the values, because we have 2 to the power that range. Okay, so machine process these numbers, and these numbers together makes a machine thinks how these numbers are there, and like that. Here we have very low values, we have very high values, so there may be some boundary. So the machine understand from these pixel values where are the edges, where are the texture, right? So this is how machine try to understand from the image. So once machine read the image, it requires learning, right? How it learns, it just like human learns from repeated observation. That's like if it is one clinician or radiologist see so many images, and it has historical data. Okay, for this kind of image, when I was seeing this kind of pattern in the images, this was the output that time. And then he has seen few images, maybe 1,000, 2,000, 4,000 images, 4,000 patient images. Then it generalized for new examples. Okay, and it keep learn from the feedback. Similarly, machine do that. Machine learn from the large amount of data set. They require so many labeled data set, especially in supervised approach. They need a labeled data set. Means if this is the image, for that image, what was the outcome? Means one-to-one mapping it requires in supervised, and it relies on the feedback, that is the loss function, similar to feedback we have in the clinical outcomes. The kind of feedback we have clinicians have, so here we have a loss function. So this is how machine versus human learns. So there are different type of learning we have discussed. Supervised learning, where we require a level ground data set. We have unsupervised learning, where the algorithm think, okay, this is the best way to represent that this similarity is more in this data set, so it make a cluster based on that. So that is unsupervised learning. And nowadays unsupervised learning, people, there are different kind of learning, that is a self-supervised learning, that is also unsupervised learning. So in self-supervised learning, we don't require the label data set, but from the latent representation algorithm learn. Semi-supervised learning, here we requires small label data set. Along with that, we can use unlabeled data set at the same time together. And reinforcement learning, just like a robotics and surgical robots, we require in reinforcement learning, basically where we wanted to control or always there is some goal that you know, that particular goal, but how to reach that goal you don't know. So it learns by the hit and trial method, and then it provides it rewards for the to reach the goal, or it discourage to if you don't reach to the goal. Right. So here is an example. You see that here we are providing the MRI images or any medical images you can provide. Here is the algorithm. So algorithm, of course, will have a back propagation, all these neural networks, and then it predicts something, right? So it predicts something, but this prediction is it correct or not correct? So we will get to know? We should have some level data set, or we should have some ground truth. Then we have to calculate the loss function. That is a feedback it is providing, and ultimately the model will learn with the help of level data set. So this is a kind of learning happens within the supervised learning approaches. And in unsupervised learning approach, we don't have labeled data set, but somehow algorithm figure out that this is the one pattern based on the distance matrix or something. Okay. And how self-supervised learning works, where we get the output, and from output somehow we get the input, and then we have one loss function between the reconstructed input and the actual input. Then we learn this data using self-supervised approach. So here we see that where we can use the AI techniques. So AI or machine learning can be used in the image acquisition and reconstruction. Image acquisition means if you see the MRI, so how we can acquire the image, and how we can acquire the data, and how we can acquire from acquired data, how we can make an image. This is how we can use the AI techniques, how we can improve the contrast, how we can reduce the noise, how we can remove the artifacts if there is some problem in the scanner. So here we can use the AI techniques. We can use AI techniques for segmentation, regression, that's very common, imaging, biomarker, and diagnosis and prediction we can use. Right. So these are the recent trend in AI, where specifically in medical imaging, you can see that AI is helping in a molecular imaging because imaging gives you only the images, variation between it provide you the difference between the one pixel to another pixel. It cannot provide you what is actually happening at the molecular level, because this is just an image, right? So nowadays AI is able to predict the molecular images. So this is one paper you can refer, and here AI is being used for the deformable registration and motion artifact correction. And in fact, this is a very promising paper. I found that AI is actually help to construct the data set during the scanning. How you should acquire the data set, and what way you should acquire data set to get the fastest scan. So here AI is being used nowadays. So this is a recent trend. Now this is the bias and fairness. As I told, that's very a lot of people work in this domain to reduce the biasness and improve the fairness. right? So for that, we requires a huge amount of data set from different for very diverse data set. We require interdisciplinary cooperation. We requires, and then we have to take on the very large huge population. This is how we can improve the fairness and reduce the biasness. So people are also talking about nowadays about responsible machine learning, because whenever we see the predictions is always tell you, okay, this is correct, this is not correct. But in general, things doesn't work like that. So whenever we see in biology or medical, it's very important that people talk about what's the mean, what's the standard deviation, how much error are there in the outputs. Okay, so whenever you have an AI model, you train that during training time. You know what is the error. But whenever you deploy your model, at that time, whenever you test, you don't know what is the error in the testing data set. So that's why the responsible machine learning came, and with the help of that, you can measure the uncertainty during the testing as well. So this is an example where you can see this is the ground truth, right? And this is a ground truth, and it is telling that this 100% network is sure that is the correct one, and this is the uncertainty in the its prediction. So with this knowledge, with the knowledge of uncertainty in the predictions, radiologist or clinician can have better idea. Okay, so about, and they will have better, they are able to have take a decision in a better way. Okay, so here they should do the surgery or not do the surgery or something like that. And people think that the challenges in AI, people think that AI is black box. That's why we need some more interpretability in the AI models. That's why now the people start talking about the physics informed deep learning methods. So most of the methods are data driven methods. So you have a huge amount of data set. You train that data set on a network. You get some output. Okay, but how the input data is being transferred into the output? Okay, what is happening actually inside, and it is whatever is happening, is it correct or not? So this kind of methods are have very limited understanding. That's why people call this a black box, AI as a black box. But for a beginner, it is very good, because it is you don't need to think much about the mathematical models. You should have you can use this model for a wide range of applications, because you don't need to worry about what's physics going behind. But if you are able to incorporate some of physics into the models, and this is how we can improve the transparency and interpretability into the models. So having the data along with the physics, and that's called the physics informed deep learning, and that's improved the transparency and interpretability of the models. So this is how scientists and people can believe more on the AI. So finally, I have a quote from some leaders, technology leaders. Satya Nadella told that he is a Microsoft CEO. AI is perhaps the most transformational technology of our time, and healthcare is perhaps AI's most pressing application. Tim Cook, CEO of Apple, mentioned that healthcare is a business opportunity. If you look at it, medical health activity is the largest or second largest component of the economy. Google Health, from Google Health, Tura told that we think that the AI is poised to transform medical, delivering new assistive technologies that will empower doctors to better serve their patient. Machine learning has dozens of possible application areas, but healthcare stand out as remarkable opportunity to benefit the people. So yeah, so with this quote, I would like to stop here, and in case you have any question, I would like to answer those questions. Yeah, thank you.
Thank you very much, sir, for such an insightful, informative, and inspiring session. We now move to the question and answer session. I request all the participants to kindly post their questions in the chat box. We will take up as many questions as time permits. I encourage everyone to actively participate and make the most of this interactive session.
And the participant can also raise your hand if you want to ask any question. I will unmute you.
If you have any doubts, any query, please feel free to ask.
Okay, in case you don't have question right now, please feel free to ask anytime with me on my email, or you can contact with some other ways, maybe on some social media. I will happy to answer any question.
Hello, Professor Munendra.
Yeah.
Sir, thank you very much for a very insightful talk. And this area of AI, you are getting used in medical image processing and medical imaging is really very useful for the humankind. And I am also inclined and just want to know how to connect with you so that we can find some common interest area and uh, take take it forward. So if you can please share your maybe email ID and the contact detail, I definitely would like to connect offline sometime to get more insight towards the research in this particular area.
Yeah, sure. I would be really very happy to means collaborate with any potential application or any common interest we have. So yeah, definitely we can together we can do something on medical imaging with AI. So yeah, you can get this information from anywhere. You can just if you Google it on NIT GSR website, you will get my contact number, phone number, or you can get my email ID as well. Please feel free to write or call for any collaborations.
Sure, sir. Yeah. Thank you very much.
Thank you.
And sir, one more question. Suppose, is there any, worldwide website available where we can see what is currently happening and, or what is the stage of this particular advancement in terms of the medical imaging? So like now, various research groups are working on different image processing using AI. So some are working on cancer detection, some are working on different imaging. So is there any consolidated platform where one can see the what is going on in this particular area,
Yeah.
or it is more like a distributed only and there is no consolidated information or single point information available?
So to means because it's very difficult to track everything that you mentioned, that because you want a lot of information at the same one platform. So really, so many things are there. But I believe that means probably conference pages will be good to visit. Those are very reputed conferences, like in MRI, ISMRM, means whatever most advanced work you see that will be being discussed there. Yeah, and then later on it comes into journal papers. Similarly, in medical imaging, I'm missing that name. Yeah, but that conference is there in medical imaging. MICAI, yeah, MICAI conference is there. So probably if you visit the MICAI page, you will get a lot of information. But it is not everything. But yeah, most of the information you will get there.
Sure, sir. Thank you very much, sir. Thank you.
Sir, there is some question in chat box also.
Okay. What is question? Okay. Then question, please raise your Okay, so people are asking someone is asked that they have covered the ML and they want to study the deep learning. Okay, so see, deep learning is of course relatively uh, new area. So you can get so many things. Of course, so many books you can get. but things are going so fast that people don't have that patience to read whole book. So I would suggest for those people, there are few video lectures on YouTube, from Andrew Ng. He is a very renowned in AI. So Andrew Ng, he is from he was working in the Stanford University. So deeplearning.ai. So there are so many videos for deep learning. Okay, people can refer from there. And 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 there is one more. So this is deeplearning.ai is on YouTube, as well as they can directly Google it. In Coursera, there are so many courses by the Andrew Ng, and people can refer to understand the deep learning. And then there is, I am forgetting name, but yeah, I can just suggest that some one professor is from Columbia University. I guess Karun Nair, something Professor Nair from Columbia University. He has very straightforward, very simple language, very good animation videos he have. From there, people can try to understand the AI with imaging things. People can try to understand.
Okay. Suman ma'am, do you want to ask anything?
So there is one more question: what skill we should focus on as a beginner in AI field? So skill, I believe, means if you if you have basic understanding of Python, how to write the codes in Python. Okay, so this would be the skill, and then knowledge of the different methods is also required. For that, they have to learn or implement some networks from the very fundamental to the recent one. Not very recent one, but yeah, fundamental. They should start from the fundamental, and the Python. They should do that. They should have better programming skill.
Hello. Hello.
Yes, ma'am.
Hello, sir. I'm
Yes.
Dr. Suman. Can you hear me?
Yes, we can hear you.
Sir, what kind of data you required for medicinal chemistry student? Like you need a data set, or you can get only you can do it for only one molecule. As I know, ki more than one molecule, more than data set are required. So many data which we don't have actually, like
So
their physical data.
yeah. So physical data means is really very interesting to work with. But initially, if you don't have physical data, so there is so many data sets are there on protein folding, drug discovery. There are so much data set is available, and for in silico study, people work on that kind of data set. So there is so many data sets are available. So if you please try to search, you will get it. So yeah, there's so many public data set available for that.
Okay, sir.
We will take one question from Yuvraj. Are you available? Yuvraj, are you there?
Hello.
Yes. Yes, Yuvraj.
There is one question I can read from here. How AI currently helping in MRI, more in image reconstruction or in disease diagnosis? So yeah, AI is helping in MRI. That's true. That image reconstruction. Image reconstruction means when the patient is in the scanner, and then very first from that MRI signal has been generated, because ultimately we get the signal, and that signal is being acquired on a one two-dimensional plane, that is called a case space data. And from the case space data, that we call the raw MRI data, and from that data, that is, we take the Fourier transform, then we get the actual MRI image. Basically, acquired data look like we cannot understand anything from the original acquired data from the MRI, but when it is converted into the full transform, then we can see actual image. That is called image reconstruction. So there are a lot of scope to work in a MRI reconstruction nowadays, because for that people requires a very small very some understanding of the MRI. That's a very promising area, and AI is really helping in that. People are trying to get different ways to acquire the MRI signal, and from how to convert from MRI signals to image, and from case-based data, and from how to acquire the sparse case-based data to actual MRI images. This people are working in that area.
Okay. Now, Krishna.
Yes, sir.
Yes.
Okay, sir. So should we move towards our validatory session if no have
Yes.
any doubt?
Yes.
Okay, sir. Now, as a token of our gratitude and appreciation, we now proceed to the felicitation ceremony. I respectfully invite Dr. Gaurav Kumar to kindly felicitate our invited speaker, Dr. Munendra Singh, by presenting a digital memento.
Okay. Sir, thank you so much, sir. Munen sir, for accepting our invitation, and on behalf of our Department of Biotechnology and Bioengineering, School of Biosciences and Technology, and Institutional Innovation Council, Galgotias University, I would like to offer this digital memento to you. So kindly accept, and
Thank you, sir.
as a token of gratitude.
Thank you, Gaurav sir. That's giving me opportunity to interact with the very nice audience. They had a wonderful questions. I was really thankful to you for inviting me in this talk.
Thank you, sir.
Thank you, sir. Once again, our sincere appreciation to Dr. Munendra Singh for sharing his valuable expertise with us. Before we conclude, I kindly request all participants to fill out the feedback form, the link for which has been shared in the chat box. Your feedback is extremely valuable to us and will help in improving future academic programs. With this, we come to the end of today's session. Thank you all for your active participation and continued support. We look forward to your presence in our future academic and innovation driven initiatives. Have a wonderful